It's been a long time. Researchers in AI been trying to get sparsity implemented with large language models or simply neural networks. The concept of sparsity in AI can be traced back to early 2000s when researchers began exploring ways to reduce the complexity of neural networks. One of the early proponents of sparsity was Hakares, which is a Japanese AI startup founded in 2014, which adapted sparse modeling or SM technology developed in universities around 2000. There has been a lot of research going around sparsity. In very simple words, large language models have achieved great success, but their vast number of parameters result in high computational costs and memory requirements. To address this, researchers have turned to sparsity, which involves efficient activation of only parts of the parameters for inference. That is the whole idea behind this whole research, and that is the topic of this video where I am introducing you a new sparse llama which is 70% smaller, 3 times faster and quite accurate. While it does that, it is quite fast and small because it uses sparsity. And what is sparsity? Sparsity involves efficient activation of only parts of parameters for inference. In general, sparsity can be achieved through techniques like pruning, NM sparsity, entropy based sparsity allocation, and few other techniques. By reducing the number of active parameters, sparsity can significantly decrease computational costs, memory usage, and inference times, making LLMs more efficient and scalable. Recent studies have shown that sparsity can be achieved without significant performance degradation, making it a promising approach for efficient LLMs. The researchers continue to explore sparsity in various applications, including natural language processing, computer vision, and speech recognition. And that is why I believe that this new research with the collaboration of Cerebras and NeuralMagic has really achieved a good milestone by combining state of the art pruning techniques, sparse pre-training, and purpose built hardware. They have unlocked the unprecedented level of sparsity in LLMs, which has resulted in 70% parameter reduction without compromising accuracy, and that is not a small thing. As I mentioned earlier, that searching for sparsity is not an easy task, and it is not it hasn't been started yet. It's been an old thing since 20-30 years ago. People were trying to achieve it, and this quest for sparsity in these models, with the goal of reducing computational and memory requirement, has just taken to another level with this new research. We all know that pruning techniques which remove less important weights have proven effective in shrinking the size of computer vision models. But applying these methods to LLMs have so far not yielded great results because LLMs operate on high dimensional data and require a vast number of parameters to capture the complexity and nuances of language. Removing weights through pruning can disrupt the delicate balance and relationships between these parameters, leading to a significant loss in accuracy, particularly in downstream tasks such as chat and coding. This degradation in performance and the complexity of training is the reason why no major LLM today employs sparsity. So now we know the problem. Another thing is that, and which is the obstacle for sparsity, is the limited support for sparsity on GPU hardware. GPUs such as NVIDIA H100 offer only a very limited sparsity option. So, for example, allowing 2 out of 4 adjacent weights to be sparse. That's it. And this 2 to 4 ratio structured sparsity constraint is a significant limitation for LLMs, which are highly varied by nature and rarely follow such a predictable pattern. So that is why, as you can see on your screen, that GPU sparsity is not being used that much. And you can see here that the sparsity levels for the weight sparsity on NVIDIA B200 are not that good, but if you check it out with Cerebras, it is quite good. Now, the story doesn't end here. This is where Cerebras and NeuralMagic have done wonders. So, as you look on your screen, this is a new approach which is called as sparse fine tuning. And this sparse fine-tuning overcomes the limitation of previous sparsity technique for LLMs by leveraging the CS3 support for unlimited unstructured sparsity. This method combines one-shot pruning, sparse pre-training, and fine-tuning on specific datasets to create highly sparse LLMs without sacrificing accuracy. This process begins by applying one-shot pruning to a dense model, such as Llama architecture, removing 50% of the model weight. The pruned model then undergoes additional pre-training using the slim pajama dataset developed by Cerebras. This sparse pre-training step recovers most of the accuracy of the foundation model before pruning, effectively adapting the model to its new sparse structure. Following the sparse pre-training, the model is fine-tuned on specific datasets tailored for downstream tasks such as chatbots or code generation. The resulting sparse LLM reaches the same level of accuracy as its dense counterpart while being up to 70% smaller in size. How good is that? Also, they have done some experiments and they have put it in the detail in this paper, which I will drop the link in video's description. So, for example, they have applied it on 70 billion llama and now they have this 7 billion llama. But the thing is, the only downside is that this is the Llama 2, which is quite old now. It would be really good to see being implemented with Llama 3, and I'm more than sure the work is already under progress. So that's it, guys. I hope that you enjoyed it. Let me know what do you think about it. If you like the content, please consider subscribing to the channel, and if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.